Alright, so there's nothing that really jumps at us to place next, so we're going to kind of start with some things and then massage it around as we go. First, I'm going to fix all the positions of our devices. Again, I don't know why Eagle does this, or if it's me, but sometimes we just have to do that when we switch from mils to millimeters. Alright, so next thing I'm going to do is move the RTC. I want to put it down here with ground on the left towards the bottom. Although it doesn't have to be, I think it looks a lot nicer if it's perfectly centered. And then as for how far up, I'm going to push it as far as it can go downward. That looks good. The dimension's still over here, so it'll seat nicely. And that's perfectly centered. So not 100% sure where it's going to go yet, but I'm going to just kind of place the AT-Tiny here. I want to make sure that it's high enough so I don't cover this, but I don't want to make sure it's too close here, because when we're going to wire all the routes, they're going to go around here and then connect to each LED respectively, or resistor in this case. I want the switch to be on this side, so somewhere around there. And the battery, I want it to be as close as possible to the switch because it's going to go straight into it and connect. And real quick right now, I'm going to actually mirror it, so I'm going to put it on the bottom side of the board. And I think it's just easier to connect because you don't want any wires running around here, and it just makes it look nicer. And then we have the voltage regulator. One of the capacitors goes next to the AT-Tiny power pin as close as possible. So this is pretty darn close enough. I'm going to do rats real quick to readjust the lines, and I want to make sure that it's, as much of a straight shot as we can get. It doesn't have to be perfect. And then the voltage regulator has the two capacitors on either side. So I'm going to go ahead and try and line these up. It might not be its final location, but again, you always want capacitors to be as close as possible to the pin that they're connecting. And this may help us figure out where we're going to kind of put everything. So something like that. Again, doesn't have to be, and we can massage it around if we need to later. So let's go ahead and play with that. The output of the switch is going to connect here, so let's go ahead and move that really close. I like all my power as close as possible. It really helps with power distribution. So this is kind of tight, so let's just move this guy down a little bit. I want to make sure he's on an even division. It doesn't have to be. I think it looks good. Maybe something like that. Then we can relax this. We see our switch is kind of hanging out the board, so let's just move that a little bit so that it's not violating the DRC. We can move the switch down or up. I'm going to try and move it down because I'm going to move these along with it, and this is already as close as it can get. So maybe 1 or 2 clicks. Again, it looks like it's on the top, but this is actually on the bottom, so the silk screen means nothing. So we can actually put this as close as we want here if we want. Give it a little bit of room to breathe. And then I want this to be connected or lined up with this as best as possible. So let's go ahead and move that. I'm going to do rats to readjust the air wires. So this is pretty darn aligned, so I think that is fine. And the DRC or the T keep out are not interfering with each other. So this can be a very valid layout of our design. What I'm going to do is I'm going to move this as close to here as possible. I mean, not too close. And I'm going to fix the alignment, so I'll move the capacitor. There we are, that looks good. So pretty much we have the layout of the binary clock done. The next thing we're going to do is we're going to start routing.